All right, so what we're going to do right now is we're actually going to be tracking and seeing about the adding and subtracting numbers with the same magnitude. And then we're going to look at different magnitudes. Right now, we are looking at same magnitudes. Now, what that means is our first step every time, as we just discussed, our first step every time is we need to check the magnitudes of these numbers before we do anything. As I'm checking this, I see that the magnitudes of these two numbers are the same. What that means is I'm actually going to literally just come down here and write times 10 to the 5th initially, because I know that my answer is going to end up as times 10 to the 5th, hopefully. And if it doesn't, we end up having to do just some minor modifications. But it's actually pretty simple to do that. If they have the same magnitude, this is super simple stuff. I just say 3.769 plus 4.21. Now, a couple little things I have to deal with. I need to make sure that my decimal places are lined up. Once I have my decimal places lined up, I also need to make sure that every number has a partner. So 4 and 3, 7 and 1, 6, or 7 and 2, 6 and 1, 9. I need to put a placeholder of 0 in. From here, this is very basic addition. 9, 7, 9, 7. So I end up with 7.979 times 10 to the 5th. And that's my answer. It's very simple. Does not require a great deal of effort. So what you're going to do now is you're actually going to go in and try this one on your own. I'm going to pause the video. Pause the video as well on your end. Give it a shot and check your answer afterward. Hopefully that worked out pretty well for you. Let's check. Now, the first thing I do is I verify that my magnitudes are the same. If they are the same, I come down and I write 10 to the negative 2. From there, I just need to go in and do some minor things. I say 8.14 minus 2.01, and I get 3, I get 1, my decimal comes down, and I get 6. So my answer is 6.13 times 10 to the negative 2. Now, hopefully that was reasonably simple. Go ahead and rewind this and watch it again if there was any point of confusion. Here is where things get a little weirder. So we're now looking at things with different magnitudes. Now this makes it slightly trickier. However, it's still reasonably straightforward process. My first step every single time is to check my magnitudes. Now here I see that these are different. I have one that is 10 to the 6 and one that is 10 to the 5. Now I'm going to walk you through why this works, and then I'm going to show you a much easier way of doing this. Initially I have 7.58 times 10 to the 5th, which means it's going to go 1, 2, 3, 4, 5. So I get 758,000. And then over here I have 2.871 times 10 to the 6, which means 1, 2, 3, 4, 5, 6. So I end up with 2,871,000, which means 2,871,000, whereas this is simply 758,000. Now, what that means I can do is I can actually take this decimal. That's strange. I can take this decimal and move it one place to the right. Now, when I do that, I've made this number, the factor, bigger, but it means that I can actually take one away from this 6 in the magnitude. Here's why. When I have 2, 8, 7, 1, 0, 0, 0, if I need to line these up, have my zeros, then I have 8, 5, 7, that's an 8. I notice that there's an entire extra place. Now, I'm going to show you two ways of doing this. First way is just actually putting these numbers in standard notation and subtracting. So I get, or adding rather, because I'm adding. So I say 0, 0 plus 0, 0, 0 plus 0, 0. 1 plus 8 is 9, 7 plus 5 is 12. Carry my 1. I then get 16 from this, and I get 3. So 3,629,000. You can do that. There's absolutely nothing wrong with that. The other way to do this, which could save you a little time, I'm going to do in blue over here, is by saying this. I know that I have now converted that by moving this decimal. So that number is now 28.71, and this number is 7.58. And both of these are in 10 to the 5. So I add, I get 9, that's 12, that's 16, and that's 3. Decimal place comes down. So I get 36.29 times 10 to the 5. So 36.29 times 10 to the 5. And hopefully you've noticed that this is bad scientific notation. I actually need to take this decimal place and move it one more place here, which means I'm going to come over here and add 1. So I would get 3.629 times 10 to the 6. And here I would get 3.629 times 10 to the 6. Both of these ways, let me highlight them, both of these ways are perfectly valid ways of doing this. It really comes down to which one you want to do the most. I personally like the green method over here a little bit more, simply because it saves me time. However, sometimes when you get into problems like this one, that's a little tougher to conceptualize. So what I want you to do is try this problem. Try this problem on your own. Pause the video. I will as well. We'll come back together and we will talk about it. Hopefully you were able to figure this one out. It's kind of weird because there's two things that this problem introduces that we haven't really talked about yet. First thing is we are adding and subtracting with negative exponents. Specifically, we're subtracting with negative exponents, which makes this kind of strange. Here is my piece of advice on this. You could convert this like we did over here. That's perfectly fine. I don't recommend it though, because we're talking about 8 extra zeros and 10 extra zeros. That's just super time consuming and not really worth it. So what I'm actually going to do is I'm going to make this number bigger, because remember, negative 10 is smaller than negative 8. So I'm going to make it larger by moving this decimal place, as we learned from my bizarre high school teacher and Beyonce, to the left to make it negative. So what I end up with here is both numbers. I added 2 to this. So both numbers are now in 10 to the negative 8. So what I'm going to do is I'm going to write these numbers down. So I have 2.9785 minus, because we're subtracting, minus 0.9785. well, 0, 5, 0, 5, 7, 2. Again, I've made sure to line up my decimal places as I need to. From here, I'm just going to subtract. 5 minus 2 is 3. 8 minus 7 is 1. 7 minus 5 is 2. 9 minus 0 is 9. Decimal, and 2. Now, when I come back down, I'm going to say times, I have 2.9213. I verify that this is in fact in scientific notation. I only have one number, a single digit number in my ones place, which means that we are done. And again, what I did here was I took this decimal and I moved it twice in order to make this number present more in scientific notation of -8. The reason I didn't change this one is if I did, I would have had to take this and move it twice this way, which I could have done. I would have had 297 minus 5. Instead, I had 2 minus 0.05. Both of those would have been fine. You just need to make sure that when you're dealing with negatives, you are watching what is happening and being super, super careful with that. From here, what I want you to do is come down into the test what you know. You're going to do these. You're going to do them silently. As you see, this is independent work time. If you have questions, feel free to raise your hand. And good luck.